Jumping back into our discussion on Introduction to ABAP, I think it's fair to say that a lot of what we talked about last time laid the foundation for our being able to now jump into a little bit more about the actual specifics of programming. Hang on a second, my computer is... There we go. Okay. So SAP ERP, like many enterprise information systems, is a three-tiered architecture. I think that probably was discussed in CSCI 3720, for example, that you would have taken. We talked about the fact that SAP R3, which was really the dominant global product that SAP brought to market when they moved out of Germany and really began to become a global presence, established this three-tiered architectural structure. When we say a three-tiered architecture, what we're talking about is there's a presentation layer, which is what the end user interacts with. You can see in my slide here that on the left of the presentation layer region, I have a small screen capture of the SAP GUI. The SAP GUI is the way that the end user interacts with the system, so that would be an example of a presentation layer. But notice that there are other ways of interacting with the system overall apart from the SAP GUI. We really do not use this in any of our coursework here at ETSU, but on the right side of the presentation layer region there, you'll notice a screenshot of what is SAP's Enterprise Portal product, which is a web-based interface that allows you to gain access to SAP content. And so it could well be that for a given user, the way they interact with the system is through something that would be web-based. Certainly, in today's environment, supporting users being able to interact with the system through some kind of mobile device is something that gets great attention. So the point of the presentation layer is, it is the resource that is used by the end user to gain access to the rest of the functionality. The presentation layer in and of itself does nothing. It has to be paired with the rest of the system in order to accomplish its functionality. So the second of the three-tiered layers that we'll talk about is the application layer. Now the application layer we could think of as a server that's sitting somewhere in a data center or server room, what have you, that is actually running the SAP ERP software. So we might think of that really as the brain of the system. This is where the programming logic is carried out. This is where we really define how we want to execute our processes as a business. So the application layer, you'll notice, interacts with the presentation layer as a part of the system. The third tier in this overall structure is the database layer. Now the database layer, like the application layer, is a server. So what we are perhaps looking at here is the presentation layer running on a PC, a laptop, what have you, the application layer being a server, the database layer being a server, and you'll notice the application layer interacts with the database layer, and the whole role of the database layer is to give us persistence of information. And that's why the database layer is often called the persistence layer. So the idea here is that when data is stored, when data is retrieved, the database layer is what's actually going to accomplish that for us. Now we'll talk more about this in detail later on, but you'll notice that in my diagram here, I have the IBM DB2 logo, I have the Oracle database logo here, and that's because those are two very common database systems that SAP customers will use to fulfill their persistence needs. So if we were to actually look at a corporate data center, we might see one machine that's an Oracle database server, and it fulfills the role of serving the SAP ERP system. And typically what will happen here is that given Oracle database server will have so much traffic associated with it that it will be dedicated solely to supporting the SAP ERP execution. As an aside, one of the things that companies have to contend with is when you purchase SAP ERP, you also have to purchase a database program to go along with it. So a typical company will not only license SAP ERP, they will license Oracle, or they will license IBM DB2. What's notable about that is, of course, from SAP's perspective, this is now money going to other companies. And although SAP and IBM are fairly friendly, SAP and Oracle are not so friendly. And so one of the things that SAP did a number of years ago was introduce a product called SAP HANA, which, among other virtues of that product, it allows customers to run an SAP database product for their persistence layer, which is great because SAP now can not only get the money from licensing an application layer product to a company, but also the database product to a company as well. Now, how does this relate to what we have to concern ourselves with in the context of ABAP development? Well, we're still looking at the same layers as we talked about a moment ago. We actually do ABAP programming in the SAP GUI. So you will write your programs on or in the presentation layer. Similarly, when someone runs your programs, their input and output from the system will be presented to them by way of the presentation layer. As an aside, you will see in your book, in one of the chapters that you will read, reference to doing ABAP development in Eclipse. Probably some of you have done some programming in Eclipse before. That's another option. At this point, it's not a very mature or commonly selected option for most developers, but in that situation, the Eclipse IDE would be fulfilling the role of presentation layer. So we could swap out other presentation layers into this, but in our experience, what we're going to most typically see is using the SAP GUI. Well, that's where we do our programming. That's where our program output will be presented to us. But the program itself will actually run on the application layer. So this is very much like something that you might do in a web programming context where the web server might run a program and then send the output back to the user's browser to be displayed. It's a typical client-server model here with the application execution happening on the application layer. Well, the other tier, we've already alluded to one of the major things that it does for us, and that is our data storage. So our customer information, our product information, all of that is in the database, which is in the database layer, which our program may need to access that information, it may need to modify that information, it may need to add to that information. Certainly there's a lot of interactions possible here, but the actual persistent storage of information will happen on the database layer. Now, if you think about writing a typical computer program, you might, in your program, create variables and objects for the sake of doing calculations. Well, those would be created on the application layer. But you might go to the database layer for sake of retrieving information into those variables, and then as a part of your programming logic, you might take data that was calculated and stored in a variable and push it to the database layer for ongoing storage. So that's the nature of this interaction here. But notice one other thing that the database layer does for us, which sounds perhaps a little bit odd, is that's where our programs are stored. So for this class, it's not like you need to make sure that you have a USB stick or something like that to store your programs on. All of your programs are stored in the system. There's no files outside of the SAP ERP system. It all just exists in the system, And in fact, there's one database table in the database that has all of the ABAP programs stored in it. So when I say that the database layer takes care of persistence, that's not only persistence of the data, but that's persistence of our programs as well. Any questions about this so far? All right, so let's look through a hypothetical interaction scenario with ABAP and the three-tiered architecture. So I've changed my diagram here to make the layers vertical because it makes this slide a little bit cleaner, but we're still looking at the same fundamental structure. So the user sits down, logs into the SAP GUI, and runs a transaction. Or as we established last time, running a transaction is essentially running or executing a program. So the user keys in a particular transaction code or double clicks on something to launch a program. And what that does is that sends a message to the application layer. Hey, this user wants to run this particular program. So the application layer will take that information and go out to the database layer and retrieve that program from what's called the program repository. The program repository stores the object code associated with a particular transaction. So the idea here, it's not exactly the same process, but in other languages that you have developed programs in, for sure you have compiled a program. Well, the executable code for an ABAP program is found in that program repository. I don't know if you've ever had this experience or not. I have with moderate frequency. Sometimes when you log into the system and execute a transaction that perhaps has not been executed in a while, it seems like it takes a long time to get started. And you might sit there for 30 or 45 seconds wondering if something's gone wrong, and maybe down in the status bar you see like indications that the computer's doing stuff, but it hasn't yet painted your screen. Well, that's because if something hasn't been executed in a while, the system has to pull it out of the program repository, perhaps update some of the program linkages and things like that before it's ready to run. But if it's something that has been run regularly or recently, the program or the system responds almost instantaneously to your program execution request. So the user has run a program that resulted in a message being sent to the application layer. That results in a message the application layer sends to the database layer. The database layer sends back the program code to the application layer. So now the application layer loads up the program on one of its processor engines. And you'll notice that I've illustrated here the program, of course, has logic to it that was written by either SAP or a developer. Well, as a result of that program logic, a screen gets painted on the user's computer requesting some kind of input from them. Now, you do have some transactions that don't really request any input from the user at all. They just immediately paint output. You might recall, for example, in playing ERP Sim, that there were a lot of reporting transactions that you just keyed in the transaction code, hit enter, and the screen was painted with a table of output, and it wasn't like you had to key in anything else. Other transactions, you ran the transaction code and a screen came back that you had to fill in some fields and maybe hit the execute button, and then the logic would continue. So in this situation, the application layer sends a screen to the presentation layer which displays it. The user types in some information, sends that information back to the application layer, and typically that information is going to be retrieved into local data variables, just like you see in other programs that you write. And so this particular user input is stored in this variable, and this particular user input is stored in this other variable. And now, of course, the logic of your program is going to continue. Well, it may well be in a typical execution scenario that you're going to take the information from the end user and you're going to have to use that to go out to the database and retrieve information. So the logic of your program might have embedded in it, for example, a query. and a portion of the contents of that query, maybe the where clause, for example, will be based on data that came from the end user, but that gets sent to the database. The database system executes the query, retrieves a result set, and sends that result set back to your program. So now we're back to the application layer, and at that point, your program may send something back to the end user. Now, of course, this could be the end of it, but maybe for a fairly complex program, the user has the ability to enter more things or to do other things on the application layer, which basically just continues this pattern now of they do something that results in a message being sent to the application layer. The application layer interacts with the database layer, and we now have this interaction back and forth between all of the different layers. So every one of these pieces is extremely critical. The key thing to note here is the work done by each of the layers. The presentation layer is fundamentally about just gathering information and displaying information. We'll talk later in the semester about screen programming. We do have the ability to do some programmatic type things on the presentation layer. By that I mean things like user input validation. We can tell the presentation layer to only take numbers in this particular field. And if the user tries to type something other than numbers, that input would be rejected. And the presentation layer manages that on its own. So that we do have some ability to control that. But clearly, most of the work here is being done by the application layer and the database layer. We will develop this concept more as the semester goes along, but balancing the workload between these two different systems is a key element in maximizing the performance of our system. The old school philosophy used to be database servers have a lot of workload on them. Therefore, we don't want to make them do anything really, really complicated. We want to do more complex things on the application layer because its workload tends to be comparatively lighter. What do I mean by that? Well, what I mean is that as opposed to sending the database layer a complex query that might have it join together a lot of tables and do a lot of data reduction for us, having a highly optimized query might cause the database layer to have to do a lot of work. And if the database layer has to do an awful lot of work, it's going to slow down system performance. So what we historically tried to do was ask the database to do reasonable things and then did some of the fine-tuning of the data that it came back to us with on the application layer. Well, now that contemporary databases have much higher performance capabilities, and we have products like SAP HANA and Oracle Exadata and IBM Netezza, which feature in-memory, multi-processor, high-performance database systems. Now the world is changing. And as I talk to companies that do a lot of SAP development and ABAP development, the big thing they say is, we really want our developers to be much better at writing queries than they used to be. And so we'll talk more about that as the semester goes on. But the interaction model here has changed as the performance capabilities of these different layers have changed as well. Any questions about this? All right, so I mentioned last time that one of the things that makes working with ABAP unique as compared to, say, sitting down and writing a Java program is you're writing a program in a fairly complex, well, not fairly complex, in a complex pre-existing environment. So there's a lot of stuff in the system already that has been given a name. So we have to be very, very careful in our naming convention not to break something. And by that I mean we'll develop the concept of a data dictionary more in our class practices, but you're familiar with the concept, I trust, of a data dictionary. Well, maybe in the data dictionary, there's a pre-existing data object that has a certain type definition associated with it. Or you could think along the same lines of a database table that might already exist in the database. If you come along and say, I want to create a database table called this, and that happens to already exist in the system, if you do something to wipe out that table and replace it with your table, you can easily understand that you might just have broken some critical piece of system functionality. So the system protects us from doing things like that, because name collision, either meaning name collision with system-related things or name collision with other users, can break existing functionality. Now remember what I said before, all programs are going into a standard program repository. So if you were to try to create a program called Hello World, and you wrote your program and saved it, and then one of your classmates came along and wrote a Hello World program, their program would overwrite yours. Because, of course, we have to have uniqueness of names. So we have to be very, very careful to protect ourselves from problems that might come from inadvertent name collision. One of the ways, yes?
Would the program that has the same name, would the most recent one always overwrite the old existing one?
It depends on what you mean by most recent, because when you write a program in your SAP GUI, you are writing it on your system and on the application layer. At some point, and you'll see this in your lab, in your first homework, you activate the program. Activating the program checks it into the repository. So there could be a more recent copy on the application server than what's in the program repository. So conceptually what you said is accurate, but sometimes we have to think, okay, am I working with the one that's in the repository or another one?
Does that fall into the case as long as everybody's under the same client code?
Yes.
So
Well,
about your username and password, you can change other people's if they're in the same client.
yes. And it even goes beyond client. That's a great question, because multiple clients might be using the same database layer. So now we have the potential for something that I do in my client to interfere with something in another client that happens to be sharing the same persistence layer. So yeah, I mean, there's a lot of opportunity here for us to cause headaches for ourselves. So one way that SAP protects us is they say, okay, look, we call letters A through X. You cannot create things that are persistent in the system that start with the letters A through X. So right away, my example here of creating a program called Hello World, that's not going to happen, because Hello World starts with an H, and SAP won't let me do that. Now, you will probably make this mistake, and over the course of this semester, we've got a smaller class this time than sometimes. I'm going to bet that over the course of this semester, I'm going to get 2 or 3 emails from people. You won't do this like in the next 2 weeks, but around week like 12, when you get really tired and you start doing things automatically, I sometimes get emails from students that say, something's wrong with the system. I tried to create a program and it's asking me for a developer key, and I put in my developer key and it still won't let me create my program. And I'll ask them, what'd you name your program? And they'll send me back the name, and I'll remind them, no, program names have to start with the letters Y or Z. And what will happen is, if you try and create a program named Hello World, the system will basically let you try, and it'll pop up a screen and say, hey, give me your developer key. And what it's looking for is a developer key that only someone who works for SAP as a developer would have. So it's kind of going to let you think you're doing okay until you go to save it, and then it's going to come back and say, no, you can't do that. So Y and Z are the letters that we have to start our database tables with, our program names with, anything that has visibility and persistence throughout the system. Now, if I create a program, the name of that program has to start with a Z. But in my program, there might be variables that I use for calculations. Those don't have to start with a Y or a Z. Just the things that have visibility in the global environment. Now, your book points out something that I confess I didn't know until reading your textbook. There's actually another letter that's acceptable. SAP will let you use T for test programs, but they don't promise that they won't wipe those out when they do updates. Okay? So the rule of thumb is just use Y and Z. And I've dealt with some companies doing consulting work where they've done some things like they say, okay, all of our in-house developers are going to use the letter Y, and whenever we subcontract out work to an outside company, they can start their programs with the letter Z. And it gives them kind of a way of differentiating what they develop in-house versus what's developed outside. Companies can come up with their own particular naming convention, and they need to, but the bottom line is it has to start with a Y or a Z. Your first homework will explain to you that in this class, all of you have system login names that start with the letter Z. And we have to avoid name collision. So as a point of fact, all of your programs will begin Z, whatever your login name is, underscore, and then the name of your program. So we saw last time that I took user account 035. So if I wanted to create a Hello World program, I would just call my Z035 underscore Hello World. And now I know that I'm not going to collide with anyone else in the system as long as other developers similarly tag their programs. And that is a convention that is commonly followed in SAP development in a commercial environment where different developers will have different kind of prefix codes to identify their work. Now, in addition to this, it is necessary for a system administrator to go in and say that this system allows modification, it allows programming. I logged into, let's see if my SAP GUI is still up here. The actual transaction code for this is SCC4. You'll notice that this tells me that on this application server that we are running, there are actually 27 clients. So not only do I have to be careful not to collide with your work, I have to be careful not to collide with anyone else's work. So I have to hope that all of these other clients are following a naming convention similar to ours, and they should be. Now, our client is 313. That's this right here. So if I go in and we look at the details on this, you'll notice that this says protection level 0, changes are basically allowed here. So I can program on this client. A system administrator could come in and say no changes allowed, and could similarly change the protection level. And at that point, no one could do any programming in this system. Okay? So there's that kind of administrative control. But the big thing that keeps end users from actually doing development is they have to have a developer key, which I emailed you, and you'll see how it works in a moment here, but that key is dependent to a particular client and a particular username. Now, the good news is you really only have to put that into the system one time, and then you can basically forget about it from that point forward, because this is kind of like an activation key when you install Microsoft Windows. You put it in one time, it checks to make sure it's a legitimate version, and then you basically can forget it. Well, user accounts by default can't do ABAP development. So the first time you try and do ABAP development, it's going to ask you, it's going to tell you, you're not a registered development, please put in an access key. So if you worked for a company, your company would have to give you an access key. And in actuality, they would request that from SAP. SAP would generate that particular key, give it to you, and then you could use that for development. As a point of fact, when companies buy SAP for use in their organization, their contract will typically say something like, SAP will provide you with a certain number of developer keys. And at that point, you then dole them out to your developers, and if you ever go beyond that, you may have to pay SAP some additional money. I don't know how hard-nosed they are about that. But what this does is keeps just any old person in our organization from being able to go in and write computer programs, because clearly, we don't want that to happen. Just as an aside here, something that I think you will find interesting, I'm going to show you real quick a database in the SAP system. Transaction that I just ran here, SE16, launches the data browser. This is kind of interesting because this is an example of what I talked about a moment ago. I just ran a program by executing that transaction code that resulted in that program being retrieved, data being painted on my screen, and now I'm going to type something in there and hit another button, and that's going to result in some more data being painted on my screen. So just realize that on the application server right now, there's a program running that I'm interacting with. This particular program, all it does is allow the user to put in a database table name, and then they can browse the contents of that database table. Well, I'm going to put in here TSTCT, and then let's look at the contents of that particular table. Now, this is a very, very big table. How big is it? Number of entries, 454,000 rows in this table, which I would say by SAP standards would qualify as a medium-sized table. We will see tables this semester that have millions of rows in them. This is one reason why I say don't ask the database to do something really, really technical, because it may take it a while. Well, one of the things that I can do here, as opposed to retrieving all of those roles, I can essentially put in some where clauses to limit the result set here. And this field right here allows me to limit the language associated with the particular fields. And I'm going to tell it I just want to look at English. And let's see, when I limit it to that, now my result set has dropped down to 92,000 results. Well, what is this? These are all of the transaction codes that are installed in the system. Just English language transaction codes. And it's only showing me the first 500. I could override that if I was inclined to do so, but that's fine for our purposes because we just want to get a sense of what's in here. This is the transaction code and a very short description of the transaction code. So realize what we're actually looking at here. This is 92,000 plus programs for the English language. Now what I love that's really fun is I'm going to go back here now and I'm going to pick another language. Let's do, and I like the ones that use non-typical characters. And by the way, our system does not necessarily have all of these languages in it. Let's see if we have Vietnamese in the system. Okay, we don't. I checked Czech, no pun intended. German, I know we have German in the system. Okay, so here's the transaction codes and descriptions, but now we're looking at in the German language. Okay, so once again, when I say robust, large environment, and why we have to take care to avoid name collision. You might not have ever seen this before, but you can have transaction codes that begin with a slash. Since this table is sorted in alphabetic orders, those populate to the top here. But I could not create a transaction code called /ASU/maintain and not overwrite what's already in the system. Okay? So we have to be cognizant of that and have to be careful to stick with our corporate naming convention. Questions so far? All right. Most companies that run SAP ERP, I would dare say every company, but I'll stick with most. Yes, sir?
Does every program have a transaction code?
No. I can elect to make one, but that's why when I said that there was 92,000 programs there are far more than that in the system, that there's a transaction code that I can never remember the name of, that you can just type in a program name and launch it that way. And every program that has a transaction code would be launchable that way, but a whole lot more would be. As an example, in this class, for homework 1, you're going to create a program and you're going to tie it to a transaction code. That'll be the last time we do that all semester, because all it does is it adds about 10 minutes of work to the process, and nobody else is going to be running it anyhow, so there's no sense in us doing that. Okay, good question. Other questions? Okay, so if we are running SAP ERP, this is a mission-critical piece of software for our company. We do not want to hire a brand new developer and turn him or her loose on this extremely valuable corporate asset. So we need a strategy for development that takes that into account. Most organizations that run SAP ERP, and this would be true for other enterprise information systems as well, actually maintain multiple systems. And you'll notice that I refer to them here with 3- and 4-letter acronyms, which are typically used. There will be a development system, a dev system. That's where the programmers work. There will be a separate testing system, a quality assurance system. There will be the production system that everyone in the organization works with. And then there's a training system. The training system is kind of special purpose. It sits off to the side. It's essentially a sandbox system. And you can guess what we use it for. This is training new employees, whether those employees are developers or people that work in the warehouse or whatever have you. It's not live. So our primary set of systems are this development, testing, and production. So what will happen is we will write our programs in the development environment. Why do we write them there instead of in production? Well, you write a program that does something very, very bad. You only want to do that on the development system. You don't want to mess up the production system. I was talking to a professional, very, very highly regarded at a company in this region, who does a lot of development and advanced database work. And he has, as a result, very, very high level of authority in the system. Well, he was on a coding marathon at one point trying to get a project done. And he did the whole thing where, he was working really, really late, so he decided to go to bed, and he didn't log off or things like that, and got up the next morning and went to his system and just started typing some stuff. And according to him, kind of before he realized what he was doing, he had dropped a critical system table in the production environment. And he said literally 30 seconds later, phones start ringing everywhere, and he's essentially taken down the system. Now, he knew enough to very, very quickly be able to restore that. You can't have that happen. You know, he said he woke up, it was like the middle of the night anyhow, so it wasn't like, you know, if this had happened at like 1 o'clock in the afternoon, he could have lost his job because of this. But he was kind of able to recover quick enough that by the time everybody else showed up for work, they all had a big laugh about it, kind of thing. So we have to protect our production environment. So we create things in development, then we move them from development to testing and quality assurance. And then when we're happy with that, we move it to production. Now, my question for you is, why do we need that quality assurance system? Why can't we just go from development to production?
There's always these bugs in any code. You just need to test it either black box, white box, however you do it.
Okay, so why can't I test it in the development system?
Well, your eyes, the testing people probably their only job is to break it. So you're verifying the security and the quality.
Okay, all right.
The quality assurance.
Don't argue with anything you said. That's all good. There's another piece, though, that's missing from that explanation. Why can't I? Well, first of all, let's establish we should do testing in the development system. You want to test it out thoroughly before you ever move it from development into testing. But why do we have to have that testing system? Think about a development system. There's a lot of stuff in the development system. There's the program that you're writing. There's programs that all these other developers are writing. It does not mimic the production system because there's a lot of things that are in the development system that haven't yet made it themselves into production. It's kind of like development is where all the little baby programs are, and someday they're hoping to like grow up and move into production. But you know, it's kind of like there's lots of stuff in the development system that's not going to be in the production system. So we want to make sure that my program that works great on the development system will still work when we move it to production, and it's not dependent on something else that only exists in the development system. So what we do is we have the development system, which has a lot of stuff in it. Then we have the testing system that, as best as possible, mirrors the production system so that we know, as best we can determine, that if it passes testing in quality assurance, in testing, that it will be okay in the production system. One example of a difference. A production system would, for example, have live corporate payroll data in it. A testing system, a development system would not have live payroll data in it. It would have dummy payroll data, same tables, but maybe bogus names and bogus amounts. Similarly, in the production system, we might have a database table that contains transaction records, and there are millions of them. The development system has the same table, has some data in it, but not at the same scale. So what we have here is this segregation between these systems. And so what will actually happen periodically is the system administrators who manage our system will periodically copy the production system to be the testing system. You know, maybe once a week we do that so that the testing system replicates as best as we possibly can the production system. Because what we never, ever, ever want to have happen is we never want anything to look really, really good in development and testing, and we move it to production and we have problems. Does that happen in companies? Yeah. That's why companies have to be incredibly careful about this. Now, I'm going to skip a slide here real quick and just show you this picture right here. This picture illustrates what I was just talking about. We do our development work in the dev system. We will eventually transport that from the development system to the quality assurance system. From there, we will transport it into the production system. And notice for the production system, I kind of have this multi-rectangle effect here. That's because for most companies, even the largest of companies, I only need one development system. I only likely need one test and quality assurance system. But if I'm a global company, I might actually have multiple production systems that are separate servers that are all peered and dynamic duplicates of one another. So transporting into production might actually mean moving it into a set of systems. The key part of this right here is this concept of a transport. Everything we do in ABAP development is in recognition of the fact that this is how we develop. So let's back up a little bit here. When I create things, I create them in what are called transports or system transports. And the way I like to think of this is like a boat or a barge or something like that. So what's going to happen is I'm getting ready to work on a new program. I'm going to create a new boat, create a new ship. And everything that I create related to my project is going to get put in that boat. And at some point, I'm going to be done with my project, and I'm going to be ready for someone else to test it. I'm going to be ready to take it into quality assurance. So I'm going to send my boat into that other system. Well, my boat here is a metaphor for this concept of a transport. So every program I write will go into a transport, acknowledging the fact that at some point it's going to move from one system to the next. So I start from day one creating a transport. The other thing that happens here is we have packages. Packages are bundles that I create of related elements. I could put a single program in a package. I could put a dozen programs in a package. So if we like my metaphor here of a ship, I have to create a transport, which is like a ship. I will put at minimum one package in that ship, okay? I could put a dozen, I could put as many packages in that ship as I want, but I always have to have a transport with a package that has my program in it. Now what this does is this just gives me a way to, if I'm working on multiple projects, to have maybe a different package for each project to give me segregation of workspace. I could be working on a big project, and everything related to that project is going to go into the same transport, but there are 4 developers, and each of those developers has their own package that they're going to be responsible for, if you will, working on in the transport. So the idea here is we kind of start development from day one, understanding that the life cycle of this program will cause it to move from one system to another system over its life cycle. This gives me the ability, by the way, if I'm a system administrator, to be given a transport, and I transport it into, let's say, the quality assurance system, and let's say we test it and it fails spectacularly. I can withdraw it from the transport, I can withdraw the transport from the system and basically pull back everything that moved in. So this gives me a way not only of moving things in, but pulling things back out. So it's a very, very robust mechanism for system administration and control. And one of the jobs of a system administrator, different from a developer is kind of knowing all the development work that's going on and understanding what transport goes with what, and recognizing that this transport right here might be a preliminary set of code in support of this second transport here, so I've got to move this one before I can move this one. And so we have a lot of administrative control that comes from these transports. Transport management is a key system administration task to make sure that I always have system integrity. So you can see at the bottom of my screen here a screenshot that we'll see live here in just a moment of me creating, in this case, a package. And I have a name for my package. Notice it starts with Z. And then I give that a textual description associated with it. Questions?
So the testing system, its primary function is mostly integration.
It is every kind of testing we would want to do in our organization, but let's say things like user interface testing would probably be done while it's still in the development system. You know, we think we have a final product before we move it into the quality assurance testing system. So any kind of intermediate testing would happen in development. But once we get it into the testing system, we want to thrash it every way we possibly can to make sure that it works. We'll do things like run the system making various demands of the database and see what it does in terms of database performance. For example, one of the things a system administrator can do is run a transaction that will show all the transactions that have been run by users of the system in an inverse order from the ones that put the most load on the database to the least load on the database. So we might have a program that we think is pretty good, and in our development system it was great. But we move it to testing and actually have it do some testing using real-world data, and we see all of a sudden it only manifests itself now, but the database performance is horrible. So we're going to have to go back and refine our queries in revision. So there's a lot of things we can't really know until it gets to the testing system. But if it's something we could test in the development system, we want to do it there before. Other questions? Great question. Okay. Let's talk about the programming process, and once I show you this, we're going to kind of write our first program here together. When I am writing a program, I will first of all log into the system, log into the ABAP workbench, and either create a new or select an existing package. Okay, so let's kind of do this together. I'm hitting the wrong key here. And so I will go into, you'll learn this transaction code for sure. SE80 is the ABAP workbench. What's kind of funny to me is every other semester the ABAP workbench has had a really pretty picture here. Well, not pretty, but it's had a picture here, and so it still looks really, really odd to me that this is a blank screen. But this is the ABAP workbench. And I said that the first thing that we do is create a new or select an existing package. Okay, what does that mean? This drop down right here, I change to the word package. In all likelihood, when I come back to this system the second and third and fourth time, that will already be set up that way. But for the first time, I have to, in this case, manually choose it. There's a box right underneath the word package. This is where I type the name of a package I want to create if I'm creating a new one. Now, it's very, very small on my screen for some reason, but next to this field, there's a drop-down box and there's a glasses box. These provide tools for me to search for packages that are already in the system, if I maybe forgot what I called something or things like that. But we observed a moment ago that we will always start our names with our account names. And so I will type Z035 underscore, and I'm just going to call this PKG, can't type this morning, 01. 01. Now, when I hit the enter key, the system will try and retrieve that, and if it cannot retrieve it, it will say, this doesn't exist, do you want to create it? You will see this convention a lot this semester. What I really want to encourage you to do is not just automatically click yes. You know, make sure that you didn't mistype something, because this is going to actually go out into the system and create a new system entity. So we don't want to do that just willy-nilly, but yeah, I want this to be created. So I say yes, and I have to answer some questions. Now you'll notice in this second field here called short description, there's this little square with a check mark in it. That means that that is a required field. I can't just hit the check mark here and go on because the system won't let me. But I don't have to put stuff in all of the boxes. I just have to put something in required boxes. So in this case, because this is an enterprise system, they want to get us in the habit of describing things so that later on, if people run across this, they'll know what it is. And if I search for it, I can search for something by description. So I'm going to do this. I'm going to write down Pitarisi for use in CSCI 4767 class demos. And I'll hit the check mark here. And now I get another dialog box. Well, let's go back to my PowerPoint slide here. Step 2, create new or select existing transport request. So I just created one of these boxes that I drew here on the board, and now I have to specify what boat that box is going into. What transport is this package associated with? So I'll go back to the system here, and notice it says request, just short for transport request. I have a few options. If I have already had created for me other transport requests, I could hit this Own Requests button, and it would pop up a list of all of the transports that are at my disposal. But as we will see here, if I hit that button right here, it shows me an empty list. Okay? So, what do? Well, in many organizations, system administrators create transports and then assign them to me. But in our system, we create our own transports because, you know, we're doing this as an academic exercise, and so we have these buttons down here at the bottom. The button that looks like a sheet of paper with its corner turned down is the Create Request button. I will click that. And it asks me, and you'll notice the only required field, well, it doesn't even say it's required, but I'm pretty sure it is I need to give this transport a name. So I'm going to call this Transport 1 for class demo. And I hit the Save button. The system creates the transport and gives it a name that it pre-populates in this field, and it shows up in red, but that's not a sign of an error. That's just the convention here. So I now have the package, and I have a transport, and I click the checkbox, and I have now just done that assessment, or done that assignment. So I now have this object, this package object that's sitting here, and it's totally empty. So, next task. begin creating a new program. I click on, in my object navigator here, the parent node, which is the package. I right-click and choose Create. Notice there's a lot of stuff I could create, but what I'm interested in creating is a program. So I choose Create Program, and it asks me, oh, what's the name of your program? Now, this is externally visible. I have to be sure that I adhere to our naming convention. Z035 underscore, and I'll just call this first program. We will not turn on top include. At some point later in the semester, I'll tell you what that means, but we leave that blank, and we hit the check mark, and anytime now we get this thing right here. You are not registered as a developer. Well, the next step in my list here is enter developer key, and I only have to do this one time. Yes, sir?
Is all capitalization, is that a pretty standard?
Yes, yes. And we'll talk more about that a bit later. But here's my developer key. And so I'm going to copy it just like you will do from the email that I sent you. And I'm going to come over here and I'm going to paste that in and I'm going to hit continue. And now it knows I'm a developer. I'll never ever have to do that again. But the very first time I create a program, I have to do that. I get this right here that once again, give me the attributes of this program. And you'll notice that none of this is actually required for me to do anything with. So I can just hit save. And now, now it's getting kind of redundant. It says, okay, make sure that you want this put in this package. Is that right? And it is. So I just hit save again. And then it says, okay, and you want to put it in this transport. Yeah, check mark. And finally, I now have my development environment to write my first program. You'll notice that the system has spotted me a comment block at the top of standard composition. And then on line 6 in this instance, we'll see the word report and then the name of my program. Harkening back to kind of the original use of ABAP, all of our programs are actually reports in the system is what that's called. So the next thing on my list is to create and debug and save my program and all of that stuff. Now, the IDE here is really kind of nice. You will come to appreciate this. You will also come to want to put your fist through the screen at certain times this semester. I'm quite confident. But it has a lot of nice features. For example, one of the keywords in the language for creating output is the word write. And notice as I start typing here, WR, it says, oh, it looks like you're going to type the word write. And so if I ever want to take advantage of that, I just hit the tab key and it'll fill that in. Notice it does, well, you can't really tell at this point, but it's doing syntax highlighting. So I'm just going to have it write out the word hi. And there's my first program, okay? I want to test it. There is an icon here at the top. Looks like a kind of a set of balance scales called check. I hit that, and down here it says no syntax errors found. It's a good idea to save my program, although technically I try and run it without saving it, which is a very bad idea. You will do that this semester, and you will want to put your fist through the screen because your program will crash and you didn't save it, and your program is gone. So you always want to save it before you run it because otherwise it can go away. And I do that. I've done that before. Students have done that before. Nobody is happy by that, okay? And I can run this now by clicking this icon here that looks like a monkey wrench. And I click it, and there's my program output. Hi, okay? Not a sophisticated program at all, but this is a fully functioning ABAP program that creates output. Notice if I screwed up and I forgot to put the period at the end of the line, I do my syntax check, and it says, notice this, the ABAP code checker is the best one I've seen of any programming language bar none. because it actually gives you really helpful feedback, and a lot of times it will contain like a link to a help document that fully explains what you did wrong and tells you how to fix it. And notice this, it says, it's not one of these generic error. It says, line 8, the last statement is not complete, period missing. Okay, that's a pretty good error message right there. Okay, now I did that. That happened when I did the code check. If I forgot to do the code check and I just tried to run it, it does the code check before it runs it. So it's not going to run anything that has a syntax error. Now, of course, I could have a logic error in here. My spec might have told me to write out the word hello, and I'm producing the wrong output here, and it's not going to check that for me. But the syntax checker here is really pretty fabulous. Yes?
Do you know the reason why it doesn't automatically save before you run the program like a lot of others do?
I think there are different ways to run the program. This direct processing in the IDE is kind of like the quick and dirty, just dump it right to execution. And I think it just, doesn't want to bog you down. If you don't want to save it, it's not going to force you to save it. So yeah, it's a great way to shoot yourself in the foot. And to my knowledge, there's no way to, toggle a control in the system that would kind of force it to do it or things like that. So, back to my process here, create, debug your program, test it, revise as necessary. When I believe that I am done with my program, and I look at it and say, what a masterful program this is, clearly everyone on the system is going to want to run this. See, right now, only I can run this program. Why? Because it's not in the program repository. Remember, we talked about the program repository? So to make it fully a part of the system and put it in the repository, I have to activate it. Activate it can be done, all of these things can be done by various menu pull downs here. I tend to like to use the icons. You might even eventually start using the F buttons. I've never learned those. But this icon right here that looks like a stick on fire or a match or whatever have you, that's the activate button. I click that. Down here at the bottom it says object activated, and now other users in the system could run this program. It's not a transaction code, so they would have to know the name of this program in order to run it. If I wanted to, though, I could make it to be a transaction code. You'll do this for your homework, but just to show you this, I think I can do it pretty quick here. Create. Oh, wait, I have to go down here to Programs, find my program, create, transaction code Z, always have to follow my naming convention, Z035, hi. Short text, friendly, hello, and this is in fact this is a report transaction. Check mark. Got to give it a description here. Oh no, actually program here. This is where I have to put in the name of the program, and I only have one. Oh no, that's the one I showed you the other day. Can't do that one. That's funny that it didn't search for it. So I will have to fill in Z035 underscore first program. Save. It also, it's fulfilling part of our package and transport structure, so I got to acknowledge that. And then I have to, got to activate this guy, transaction code. Well, let's see. I don't have activate button here, so I'm probably okay. And so I called this Z035 hi. So let's do this. Let's go out here to a brand new SAP GUI, Z035 underscore hi. And there's my program. I've installed that as a transaction code that any user in the system can use. Now let's talk about where you've seen this for. Remember when playing ERP Sim, you had like transaction code Z ads for advertising? that was a transaction code written by the ERP sim developers that they wrote and installed in the system. And it went out and collected information from you and then put it in various database tables. That was a custom transaction. Not every transaction code that was a part of ERP sim started with the letter Z, but every one that did was a either fully custom transaction or one that relied on user exits in the system to supplement what was there already. So step 8, when I'm done, I transport this. I won't show you that. We won't transport things this semester because we don't have other systems to transport to. But your first homework assignment will have you do a transport, and it looks just like doing a transport, but it's a totally dummy situation. You know, it's just set up in a way for training purposes to show you what that would look like. As an aside, if you ever are going to create something and you say, this will never be transported, it's just something that will never ever move, it's just a program that I'm writing, instead of putting it in a package of your own definition, you can assign it to the local package $TMP. I'm just telling you that for your reference. Don't do that this semester. But as a point of fact, you can actually create something that's not put into the transport system by using that mechanism. As I mentioned just a moment ago, within our development landscape, we only have one system. So when it looks like you're transporting to other systems, realize that's kind of just a fictitious presentation. Questions? Let's do one more slide and then we'll call it good. Let me give you some ABAP programming starters here to get us going. ABAP programs are made up of individual, and sometimes you'll hear people call them lines of code like you do in other programming languages. But more formally, ABAP calls a line of code a sentence, or alternately a statement. So if you ever hear someone talking about an ABAP sentence, just know that they mean a line of ABAP code. Every statement, every sentence begins with a keyword. What we looked at a moment ago was a write statement. First word in the sentence was the word write. It is conventional to code all except string literals in all uppercase. It's an ABAP coding convention. Will probably take you some time to get used to. But your programs will consist of, for the most part, all uppercase letters. So I guess, you know, people are really excited about ABAP, so we're yelling the whole program at them. Each statement ends with a period. So whereas in other languages, the semicolon is conventional, in ABAP we use the period. Statements can be indented as desired. So for the most part, it doesn't really matter whether something's in column 0 or column 2 or column 10 or whatever have you. And we do follow fairly traditional rules of indenting that I will show you as we go on this semester. But there are ways in which ABAP spacing is oddly sensitive. In some programming languages, you might write x equals x plus y, semicolon. And I know it's hard to tell from my writing on the board here, but if I truly typed what looks like I have here, that would be a syntax error. Because in ABAP, every word or every operator has to be separated by space. So that would have to be x space equals space, x space plus space, y period, no space after that final y. So while indenting doesn't matter, there are some things that are very spacing sensitive. You can have a sentence, you can have a statement extend over multiple lines. If I put a star in column 1, that means that whole line is a comment line. But any place else, it doesn't mean that. For example, this could be x equals x star y, and in that case, the star is used for multiplication. But when a star appears in the very first column, that whole line is a comment line. If I put double quotes in, double quotes are used for two end-of-line comments. So if I did x equals x plus y, period, and then double quotes and had some text here, that would be documenting that particular line. Can't use the star there because the star only designates a comment when it is in column 1.
Do you need another double quote to end?
Nope. It just ends at the end of the line. There is, in fact, no way to put any code to the right of it. All right. Now, I feel pretty good about the fact that you should be well prepared to execute your homework successfully. Let me show you one other thing so that we don't have to cover this next time. In the ABAP editor, and this is a fairly new feature that is nice. Down here in the bottom right, the very right bottommost corner of the IDE, you really can't even see it that well on the projection. There's a little button down here. If I hit that icon, it will pop up the ability for me to control things in the IDE as far as, do you want line numbers on and off? Do you want it to automatically do indenting? I'm going to come in here, for example, and I'm going to see what happens if instead of making the font size 10, I make it size 14. Okay, so I can come in and I can control facets of the development environment. That icon right there in the bottom right corner will let me do that. So if you want to play around with that a little bit, you are welcome to do so. Have a great rest of the morning, everyone. If you didn't sign in, please make sure that you do that. Not sure where the sign-in sheet went. Okay, and I'll see you guys when we get together next week.